to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students of Senior 1. I'm your teacher of chemistry. Once again, I will be with you for all these 30 minutes. I want to welcome you to this lesson, number 2 of unit number 10. You remember our unit number 10 is about the chemical equations. And our lesson of today will be talking about the using chemical symbols to write chemical formulae and conversion of word into chemical equations. You remember in the previous equations, in previous lesson, we were looking at the chemical reactions in general. And we mentioned that these chemical reactions, which represent the chemical processes, are part and parcel of our lives. We exist, or the animals exist, or even some other creatures because of these chemical processes, because we looked at some of the reactions that take place in our bodies, like digestion and many other chemical processes that also take place. We looked at the combustion of the fuels in the engines that run the vehicles, and we know the uses. We look at the photosynthesis. You remember that photosynthesis involves the manufacturing of food, and you know that we depend on those foods that are made by plants. So these chemical processes, I just want to remind you that they are very important. So in this lesson, you are required to be ready. That is very important. 2, you need to have the notebook, of course, and then put down some information that will help you along the lesson. And 3, you may need a periodic table. You may need a periodic table to look at. So let's look at what we are expected of today. So at the end of this lesson, you should be able to write symbols to represent formulae of compounds, and correctly use formulae of the compounds to represent word equations. That is what we are expected by the end of this lesson in 30 minutes that we are going to be together. So I hope we are ready and we can still move on and start our lesson. So interpreting and translating word equation into a chemical equation. So in the previous units, you could have looked at the symbols. So I expect you, this is actually reminding you of those symbols and radicals and variances that can be used to write the correct formulae of the compounds. And we are going to use these variances, the correct symbols of the radicals, and we can represent the formulae of the compounds. And as we are writing, as I'm writing on the blackboard, I will be expecting you as well to write in your notebook. So we just want to look at the table that will be reminding us about the variances and about the radicals and their variances. So this is one, we have the table. It is showing the positively charged ions, their symbols, and their variances. When we talk about the ion, do you know what we mean by the ion? Yes, an ion is a charged particle. And charges, we have 2 types of charges. We have cations and we have anions. So that is what is very important as well. So charged particles. The charged particles are referred to as ions. And we have 2 types of the ions. As you can remember, we have the cations and we have the anions, where the anions are negatively charged. whereas the cations are positively charged. So that is very important to remember, positively charged ions. So those are the two types of the ions that we have. So we're just going to look at the symbols and then their valences. So these are positively charged. We have lithium ion, we have sodium ion, we have potassium ion, we have silver ion, ammonium ion, hydrogen ion. And when you look at the balance, the valences on the other side, you'll be able to see there is 1, 1, 1, 1. What does that mean? What's the meaning of that? So can you comment on the valence in relation to the formula of these ions? Right, when you look at the formula of the ions, the number of charges correspond to the valence. So if you have charge, the positive is only 1, and then the valence will be 1. You see sodium, there is only 1 positive. It means the charge corresponds to the valence. That's why it has 1 as valence. Ammonium ion has positive, and the valence is 1. That is very important also to note, that the valences correspond to the charges on the ions. Similarly, when you look at the ions that we have magnesium, calcium, lead, zinc, iron, copper, aluminium. So but when you look at the lead 2, we have lead 2, we have iron 2, we have copper 2, we have iron 3. There is a difference there that you need to note. Why are we mentioning lead 2? It means there could be another lead. Why are we saying iron 2? There is iron 3. That's why we can't say iron. That is very important. So we have iron 3 and we have iron 2. So you need to take note of that. Iron 2 and iron 3. So this one has a valence of 2. This is the valence of 2. And this one will have the valence of 3. So remember that there are some elements that have got variable valences. So they have valences which are more than 1. So you need to remember that. When you look at the lead, for example, we have lead 2 plus, and we have lead 4 plus. So those are differences. So meaning that we have the valence, we have lead with valence of 2, and we have another lead with valence of 4. We are not saying lead only. So there must be lead 2 or lead 4. So in the cases where we have to mention the number of the valences, it means that, what does it mean? It means that there is another lead with another valence. That's why we have to say lead 2, not saying iron 2. But we can say calcium 2 ions. We're saying calcium plus. So we have only calcium 2 ions. So that is, there is no any other calcium with 2 charges or with any other charge that is stable. But we have lead 2 and lead 4, so those correspond to the valences. If we have aluminium 3, there is no any other aluminium 3. That is why when you look at the table on the screen, you see lead with 2 Roman numerals in the brackets. In the brackets over there, in the brackets, this is 3, this is 2. The Roman numerals represent the valences of those elements. And it also indicates that there is another valence of that similar element. As I have mentioned, lead 2, there is another lead 4. If you say iron 2, there is another iron 3. Copper 1, you say copper 1, there is copper 2, and there is another copper 1. So those are differences that we should note. Actually, this is reminding This is just a reminder of what you looked at in the previous unit. In some of the previous unit, you looked at the symbols and their variances and radicals. So we look at also the negatively charged ions. I also want to remind you about these ones as well. The negatively charged ions and their variances. So we have looked at the positively charged ions, which we said they are called cations. Now we are looking at the anions. So if we are looking at the cations, we have mentioned some of the examples. Now let's look at the anions, the negatively charged ions with their symbols. And this, when you look at the screen, just have a look at the screen. We have the fluoride, we have chloride, we have bromide, hydroxyl, nitrate, nitrite, hydrogen carbonate, oxide, sulfide, sulfate, carbonate, and so on and so forth. But they are negative. There are some values there. You will see a negative charge. For example, similarly, as we have mentioned before, when we write, for example, a bromide like this, and we put a negative charge, it means the charge of the bromide is 1 also. It is negative, but we are just looking at the value. How many negative charges are on bromide? It is only 1. So that's why the valence of the bromide is given as 1. When we say hydroxyl, this is the symbol for the hydroxyl radical. It has a negative here. It means that this radical has a negative charge, and that negative charge, how many negative charges are there? It is only 1. So that is why the hydroxyl has a valence of 1. When we say nitrate, this is a nitrate ion with a negative. It means that the negative corresponds to the valence. But if we say, for example, the sulfate ions, which is like this, the negative charges correspond to the how many negative charges? There are 2. And therefore the valence is 2, the valence of all of this. So when you come back to the charges which were positively charged, we said aluminium has 3 positive charges. So it means that the number of charges, as I want to emphasize that one, the number of charges correspond to the valence, irrespective of the charge sign, whether it is positive, whether it is negative, but the number, positive 3, valence of 3, negative 1, valence of 1. We may have a phosphate ion with negative 3. This is also the valence. This phosphate ion, which is a radical, has a valence of 3. The nitride ion, negative 3. This has negative 3, so the valence is 3. So that is what we need. The symbols are very important. You remember we said we are being reminded of these symbols. I'm sure you still remember them. So the steps in deriving the chemical formula of the compounds. So we remember we are supposed to write the correct formula of compounds and use this formula to represent. Remember in our objectives, we need to write correct symbols to represent the formula of the compounds, and again use them correctly to represent word equation. So in the steps of deriving the chemical formula of compounds, there are 2 steps that we are just going to look at. Number 1, we look at the balancing of the charges, balancing of charges. 2, That is 1, 2. We look at the interchanging the variances. Interchanging the variances. Interchanging variances. Variances. Interchanging variances. So this is IES. So those are the 2 steps that we need to look at when we are deriving the correct formula of the compounds. But we derive the chemical formula from the radicals that we have looked at. Remember, we looked at the radicals, and I was just reminding you of the radicals because I'm sure that you looked at this in the previous unit. So in step number 1, in balancing the charges, what do we need to do? From the name of the compound, you know the ions that make the compound. So you need to know the names that make the compound. An example that we are just going to use is sodium sulfate. Sodium sulfate, sodium sulfate. This is one of the compounds. So you need to know the elements or the radicals that make these compounds. You need to know the ions that make these compounds. What are the ions present in here? You know the sodium, you need to remember the formula for the sodium. And what is the charge on the sodium? You need to remember that sodium has valency of 1. Look at your periodic table. I told you need the periodic table as well because the periodic table will tell you the location of the element on that periodic table, and it will help you to know even the valency of that element because the group number on the periodic table represents the valency of that element as well as the charges. So this is the charge number. The sulfate, how do we represent the sulfate? I'm sure you still remember how we represent the sulfate. This is how we represent the sulfate. S with oxygen, these elements, these atoms must have almost the same size because these are atoms that represent, that appear on the periodic table. So they must have the same size. I just want to emphasize this. Don't write the sulfate in this form. Some of you write it like this. When you write it like this, please, this one is not accepted at all. Don't do this when you are writing, representing, because we said correct formula. The correct formula must be the sulfur and oxygen, at least by approximation, should be of equal size. What is the charge on this? We said -1. Now, after knowing that one, then things become very simple. What do? You need to balance the charges. You need to balance the charges. The number of charges must balance. How do you balance them? It means you would have to multiply this one by 2. Multiply this by 2. When you multiply by 2, it means we'll have positive, and we'll have positive to -2, so they will have to balance and be equal, and that is what we need to do. So we are going to interchange the valences. So the valence here, we said we multiply by 2 to make sure the charges are balancing. So we are going to do like this. Sodium, we rewrite again. You remember we multiplied this one by 2, and then we have to write it here and do like this. So when we do like this, the charges, the balance, the charges will be balancing. And this one will represent the correct formula of the nitrate, of the sodium sulfate. Make sure the charges are balancing by looking for the correct formula. Something very important, another one. Let me just give another example. Maybe you have zinc nitrate. zinc nitrate. Zinc nitrate is represented by, you need to know the formula for the zinc. Zinc is not zin, this was zinc. I'm sure you have seen this one, it was supposed to be zinc. So the zinc, what is the formula that represents zinc? You need to remember that zinc, this is the symbol for the zinc, and what will be the charge? The charge, that means the valence, because we said the valence corresponds to the charges. Positive 1. What about the nitrate? The nitrate is represented by NO3, negative 1. So what do we do now? The charges are not balancing. That is the first thing that we need to do. Balance the charges. Here we have 2 and we have negative 1. That means we will multiply by 2 this side. When we multiply by 2, that means this 2 now will be the factor that you have multiplied by. So we are going to do like this. So this 2 will come to, we'll write it in this form, just simply like this. We are going to write zinc. We write the nitrate. How do we write 2? Do we write 2 here like this? Because we said when we wrote 2 here, the 2 came down. Now, the same as we multiply by 2 here, this 2 has to be here. So what do? We need to put the brackets. Because the 2 is not for only this atom, it is for all this radical. So that is why we are putting the brackets here. Therefore, the zinc nitrate is written like this. We put the brackets. Why didn't we put the brackets here? Because this 2 is for only this sodium and it is single. So we need to remember that as well. So those are some of the examples. We may have another example here. Sodium phosphate. Sodium phosphate. Sodium phosphate. So what is the symbol for the sodium? That is sodium. And what is the charge? You need to remember all those. What is the phosphate? PO4 negative. So what are we going to do? Equate the number of charges. This is negative 3, this is positive 1. So we need to multiply by 3 so that we have all 3 positive. Positive 3, negative 3, they will cancel out. So what do? The factor here that we have multiplied here must be written as a subscript of this element. So this one will be written as sodium. You remember we wrote it. This 3 is this one that we are writing here. And then bring the phosphate like this. Now that will be the correct formula of the compound that is formed. You remember, we don't need to put the brackets here because the charges, and when you look at this compound, you'll find that there are no charges as we had because the charges were cancelled. So if we have, you can even try some other examples. And now let's proceed using that information. Converting word equation into the chemical equation. I have a number of examples that I've given. Just look at the screen. We have sodium hydroxide. We have sodium hydroxide plus nitric acid. It gives sodium nitrate plus water. We have hydrogen plus nitrogen giving ammonia. So there are a number of examples. So I'm just going to give a different example. For example, you have sodium plus water giving sodium hydroxide. sodium hydroxide plus water. So you need to represent what is the correct formula for water. This is sodium, this is water. You need to remember the formula for water. What is the correct formula for sodium hydroxide? So you need to know sodium hydroxide. How do they combine? What are the charges, as we have seen from the radicals, because this is the compound. Then this is sodium and hydroxide will be written like that. Then plus, this was hydrogen. I beg your pardon, this is hydrogen gas. So this is the hydrogen gas formed. Now that will be, this is the formula and this is the symbol. This is the word equation. This is the chemical equation. So we can have another example. We may have zinc plus hydrochloric acid, which will give zinc chloride plus the hydrogen gas. This is a word equation. How do we convert it into a chemical equation? You need the symbols to write the correct formula. What is the symbol for the zinc? You have, this is zinc plus. How do we write hydrochloric acid? HCl, small l, and then giving zinc. How do we write this? This is the chloride. Zinc has a valence of 2 and chloride has a valence of 1, so that when this one will multiply by 2 and we bring that as a subscript. Then plus the hydrogen gas. So dear students, these are some of the examples that we can use to represent from the word equation to the chemical equation. Word equation to the chemical equation. So you can use this to have the correct equation with words and symbols. These are some of other examples. We'll be able to do the exercise and practice and continue as we get familiar with these compounds. Thank you so much, dear students of Senior 1. I hope you have taken some notes for you to use because we'll need them in the next lesson. Bye-bye. Good day.